Okay, we are here for video lab number 11. And we're meeting this team for the first time. How are you?
Good.
And what is your name?
Barbara. Charlene.
Jessica.
Shatoya.
Henry.
And what was your name?
Henry.
I thought you said Eminem. Okay. Who can tell us what today's lab is all about? Yes?
Molecular structure.
Yes, very good. We're going to put together molecules today. And in order to do that, we're going to be using some beads over here to make a model of a molecule. So here are some questions for you. In the model that you're making, what do the beads represent in the model? What are the beads?
Elements.
No. Sort of.
Protons.
No.
Atoms.
Atoms. Okay. What do the different colors of the beads represent?
Different kind of atoms? The different kinds of atoms?
Yeah, what do we call them?
Protons.
No. The protons on your mind today.
Molecule?
No. Different colors? Say again.
Elements.
They're the different elements, okay? So that's where the elements come in. The colors are the elements and the beads are the atoms. How are we going to put these atoms together?
With the beads and then with the things.
We have to be more specific than the things, okay?
The stick.
With the sticks. Now here comes your duck question. In the real world, you watch MTV? In the real world, what are the sticks?
The chemical bond or
Very good, the chemical bonds. That's a good answer. He's keeping you in there right now with the first time. No, it's a good thing you didn't, because then you wouldn't have a chance. Okay, so they are the chemical bonds that hold them together. So you told me the colors are the elements. Let's talk about the colors for a couple of minutes. We have a beaker that's loaded with the different colors that we're using. If you would take 2 beads out, pass the rest down, take a bead, you get the last 2. Okay, so just take one, take your favorite color of what remains. 1 bead will do it. No, 1 bead.
Oh.
She gets 2, he gets 2. You guys get 1. Okay, now if you would hold up one of the beads and tell the class what color the bead is.
Red.
Okay, and class, would you tell me please, what does the red bead stand for?
Oxygen.
And what does the symbol for oxygen stand for? You lost your bead. Try to control your beads, okay? Symbol. O. Okay, hold up the other bead. Tell them what color it is.
Blue.
Blue. Who can give us it?
Nitrogen.
Not proton?
No.
Okay. And its symbol? N. What color is your bead?
Purple.
Okay, show it to us so we can see it. Okay. And who can tell us what that stands for? So you got to speak up.
Potassium.
Okay. Potassium. And what is the symbol for potassium?
K.
Okay. What color is your bead?
Black.
Okay. And who can tell us?
Carbon.
And who can tell us the symbol for carbon?
C.
And what color is your bead?
Green.
Okay. We're trying to figure out what that means. And it is?
Chlorine.
And its symbol is?
CL. No. CI.
No.
CL.
CL. Not CI. One of your beads. What's the color?
Yellow.
Okay. And its
Hydrogen.
symbol?
H.
And the other bead?
Orange.
And its element?
Sodium.
And its symbol?
Na.
Say loud.
Na.
Na. Okay, so these are the different beads that we're going to be using and what colors they represent. If you could put it back in the beaker and just pass it on down, put your beads back in. 2 points there, Jessica. That was a dunk, slam dunk. Okay, now, how will we know how many of each beads you're going to need to make your molecule? Yes.
Subscripts.
And what are subscripts?
The little numbers just below the letters.
Okay? And then the little numbers are part of an overall thing that's called a what?
Formula.
Yes. And if there is no number in the formula, in the subscript, then how many are there?
1.
Okay. So now that we understand how we're going to put the model together, let's see the formula for the model that they're going to put together. So if you take that piece of paper, turn it over, leave it on the desk, and face it to me, these are the formulas that you guys are going to be working with. And I'll tell you a little bit about these chemicals, because they're real chemicals, okay? You are working with a chemical that is called sodium hydroxide, which is more commonly called lye, L-Y-E. You find it in soap, and it is the reason that soap burns your eyes, and it is the reason that soap is slippery. Right? So it's a real chemical. Okay? Charlene, you're working with a chemical called methyl alcohol. Alcohol? Are you 21? What are you doing with this chemical?
Oh
It's not a drinking alcohol. It's an alcohol that's used as a fuel. Sometimes out in the Midwest, places like Iowa and Kansas, they make this stuff from corn, and they mix it together with gasoline, and it's called methanol or ethanol. Okay, so it's actually used as an additive in gasoline. Also, if you've ever gone camping and eaten on something called a sterno stove, how many of you have ever used a sterno stove before? How many of you have ever gone to like an affair, like a wedding, and they're keeping their food warm with this thing underneath it? The thing that's burning underneath is that fuel. Okay, so a sterno stove kind of looks like a big tuna fish can. And you pry the top off, you drop a match in, a blue flame comes up, and it's that stuff that's burning. Okay? This chemical that Jessica has is called carbon tetrachloride or carbon tet. It's used as a cleaner, but they don't use it anymore because it causes cancer. So when you make this model, try not to swallow any of the beads. Shatoya, you got the heavy-duty one. This is called butane. Where would you find something that has butane in it?
It can be used as heating oil, I think. Or, wait, no, lighters. So
Lighter fluid. You heard of lighter fluid? Lighter fluid. You ever see the lighters, the cheap ones that have liquids in them? That's butane that's in it. So flammable. Be careful. Don't hit the beads together too fast. Okay. And finally, Henry has something called potassium cyanide. What do they use cyanide for?
I know it's some kind of poison.
It's a poison. Okay. They can make a gas out of it or a mist. They can kill insects with it. Cyanide gas. Don't inhale any of those beads in your nostrils. Okay? All right, so now that you know what you're doing, here we have the beads. And what you're going to do is pass it around and as Michael Jackson would say, beat it. Beat it, beat it, beat it. No one can be defeated. Something like that. Right? And we'll give them a little time here to do their thing. Okay, now while they're finishing up with your models, let's do that thing I was telling you about that has to do with Men in Black. Okay, so we're going to make your face into sort of like a alien cartoon sort of character for those people that want to. So who would like to try this thing? You can't volunteer hard, you have to volunteer. Anybody? If you don't do it, you're going to kind of miss it.
Come on, please.
Okay, George, when I tell you, George. Not yet. We just have to zoom in and focus up on you here.
He has to do a funny face.
Well, he's going to do a crazy face when I tell him. I'll give you the count to 3, and then you do it, okay? And then hold your face still when you do it. 1, 2, 3. Yeah, that's a good one. That's a good one. That works good. Okay, and we'll have a chance to see this. Who wants to try one? Torian? When I tell you. Okay, 1, 2, 3. Oh, yeah. That's kind of interesting. Now, these faces look nothing like you think they look. The things that you're looking at right now, they look nothing like what just came out. So we'll try another one. Anybody else want to try one? Come on, bro. Somebody? Going once? You guys can be part of it. No, because it has to take one face, otherwise you won't be able to do it. You'll see what I mean. Anybody? Once? Okay, Matt? Just stay where you are. Let me just
I have
focus
to
in.
start before you actually.
You can't touch your face, though, okay? It just has to be, no, it has to just be your face.
Oh, then I can't do it then.
I can't
Just
do
do
it.
anything.
I can't.
I can't do
Like
it.
what?
Do anything.
Like,
Stick out your tongue.
Close your eyes on.
1, 2, 3. Yeah, that's good. That worked.
Fine.
You'll see when you see it. Okay, do we have another person like to try it? Going once? Going twice? Okay, you want to try one?
No.
Robert, you want to try one? It's like you're thinking about it.
Do it, go ahead.
He said represent.
Okay, well, you can try it. We'll do it on the next lab as well. When you see how it came out, you may want to be part of it again for the next lab. Okay, are our models done?
Yeah.
Okay, what I want you to do is turn the formulas around again, put your models on the paper so we can see it. We'll take a look and see how they came out. All right, so here we have the thing that you find in soap, sodium hydroxide, what its model looks like. A little bit more complicated, that's the alcohol. Okay, and here we have the cleaner. And over here, we've got the very complicated butane molecule. Why don't you just turn that around a little, Shatoy, so we can see it from different angles. Okay, that's cool. And over here, we have the poison. Okay, now, the next thing that they're going to be doing with those models is they're going to change them into a diagram. What do we call the diagram that they're going to produce from these models?
The structural formula.
Yeah, you actually hit yourself in the head with a piece of paper on video. Okay. A structural formula, okay? And that's why they have these yellow pieces of paper. So if you could take your models and change them into a formula, what we'll do is back off and come back when you're done. Okay, we're back and we're going to take a look down and see what their structural diagrams and formulas look like. Okay, so here we can see the similarity between those two. And here's our alcohol again. That was the soap over there. This is the alcohol over here. Here's the cleaner. Okay, and here we have the butane, the lighter fluid. And over here we have the poison. Okay, now, when they put together their molecules, there's two different kinds of ways that they come out. What's one kind of a way that this diagram is?
Chain.
It's a chain, and what's the other type of way that you can get? 3D. And sometimes you actually get a combination of the two. Some of the diagram might be a chain, and some of it might be 3D. That's called a combo. So let's see if we can decide which ones are which here. You guys in the audience are going to decide that by looking over their shoulders and together yelling out what you think it might be. Okay, so we're going to look over here first. Everybody's got to see it. So what would you call this kind of a model? Is it a chain, is it 3D, or is it a combo?
Chain.
Chain is correct. You just yell them out together, kids. Second one.
3D.
Well, it is 3D, but it is also a combo because of this chain part right over there. Okay, so that's a combo. How about this one?
Chain. 3D.
3D. Okay. How about this one?
3D.
3D. How about this one?
Chain.
Okay, so chain, chain, chain. Is that my name? Something like that. Okay, this ends video lab number